On the mist-choked morning of May 12, 1942, at Aberdeen Proving Ground in Maryland, the air itself seemed to carry the weight of failure as 5 different anti-tank weapons waited silently on the test range, each one representing months or years of development, millions of dollars in funding, and the collective confidence of military experts who believed they had already solved the problem of stopping German armor, yet all of them now faced the same unforgiving trial: strike a moving German Panzer III at 100 yards, a distance that mirrored real combat conditions, or be rendered irrelevant in a war that was rapidly proving that infantry without anti-armor capability were little more than targets. The stakes could not have been higher, because across North Africa Allied soldiers were being slaughtered by tanks they could neither outrun nor destroy, their rifles meaningless against steel hulls rolling forward with mechanical indifference, and intelligence reports arriving daily painted a picture so grim that even hardened ordnance officers struggled to read them without anger or despair. Accounts describing paratroopers dropped behind enemy lines to sabotage supply routes only to be hunted down and crushed beneath treads, their bravery reduced to statistics by physics that always favored speed, armor, and mass over flesh and bone. A German Panzer III weighed roughly 25 tons and could move across open terrain at speeds exceeding 25 miles per hour, while an American paratrooper burdened with 80 pounds of equipment could barely sprint at 8, meaning that when these two forces collided, no amount of courage or discipline could change the outcome unless technology intervened, and too often it did not. The British Piat Spigot mortar fired first that morning, a hulking 32-pound weapon praised by Churchill's advisors and born from complex engineering logic, its powerful spring mechanism launching a hollow charge bomb that theoretically could penetrate German armor, yet theory quickly dissolved into reality as the projectile arced clumsily through the air and slammed into the dirt short of the target, the Panzer continuing its steady advance untouched, followed by another miss, and another, the weapon's bulk and awkward handling making accurate engagement against a moving target nearly impossible. Next came the American M10 rifle grenade, the product of months of testing and contractor assurances, launched from the familiar M1 Garand using blank cartridges that shattered rifle stocks and bruised shoulders, its heavy warhead wobbling unpredictably in flight before detonating harmlessly in the sand, and then 3 additional designs followed, each sophisticated, each expensive, each approved by committees of experts, and each one failed in turn, their rounds missing wide, falling short, or soaring uselessly overhead, until the scorecard told a brutal story no one wanted to read. Miss, 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 and then, stepping forward into the silence, came a 24-year-old lieutenant carrying what looked less like a weapon and more like an insult to professional engineering, a length of steel pipe resembling a drain tube, reinforced with wire, fitted with a crude pistol grip, powered by flashlight batteries, and aimed using twisted wire coat hanger sights taped into place. A design so visually unimpressive that members of the Ordnance Review Board had previously dismissed it outright as reckless, impractical, and unsafe. Edward Uhl's stupid idea, a solution so simple it offended men trained to equate complexity with intelligence. Yet when Uhl raised the launcher to his shoulder and fired, the first rocket streaked downrange with shocking speed and flatness, striking the moving Panzer dead center, followed by a second hit, then a third, a fourth, and finally a fifth, each impact punching through armor with surgical precision, leaving no room for doubt, no excuses, no reinterpretation, and in that moment the entire doctrine of infantry anti-tank warfare shifted, because by the end of the day General George Marshall himself would authorize the immediate production of 5,000 units, setting in motion the mass deployment of a weapon that would become known as the Bazooka, transforming lightly armed soldiers into tank killers and forcing German panzer crews to fear infantry for the first time since the war began. Only weeks earlier, however, that outcome had seemed impossible, because in the spring of 1942 Colonel Leslie Skinner sat in his Ordnance Department office staring at intelligence reports that read like death notices, describing Rommel's Afrika Korps slicing through British formations with brutal efficiency, tanks operating in coordinated harmony with infantry and air support learned through hard experience in Poland and France, while Allied forces clung to outdated World War I doctrines and equipment that had been obsolete for 2 decades. Photographs from the Gazella line showing British paratroopers annihilated after German armor rolled straight through their positions, their boys' anti-tank rifles, 39 pounds of precision machining, firing massive .55 caliber rounds that bounced off armor plate like thrown stones, leaving only 37 survivors out of 240 men, a casualty rate so catastrophic it bordered on annihilation. Production charts offered no comfort, showing German factories churning out tanks faster than American plants could match, while American infantry doctrine still assumed that courage, maneuver, and supporting fire could compensate for technological inferiority, an assumption tanks shredded with merciless efficiency. Yet amid the gloom sat a single glimmer of hope on Skinner's desk, the M10-shaped charge grenade. Based on the revolutionary hollow charge principle developed by Swiss engineer Henry Mohaupt, capable of focusing explosive force into a narrow jet of molten metal that could burn through 50 millimeters of steel, laboratory tests proving it could kill any German tank in existence, if it could only be delivered safely, because at over 3 pounds it was far too heavy to throw accurately. Rifle-launched versions destroyed the weapons firing them, and hand placement required soldiers to approach tanks close enough to touch them, effectively a suicide mission. Tasked with solving this impossible problem was Lieutenant Edward Uhl, fresh out of Lehigh University with a mechanical engineering degree and a reputation for quiet persistence that irritated senior officers. A young man who sketched ideas compulsively and questioned assumptions others accepted without thought, handed a stack of failed proposals by Skinner and told to find a way to deliver the M10 warhead from hundreds of yards away without killing the operator. For weeks Uhl worked through every conventional solution only to watch them collapse under their own complexity. Mortars were inaccurate, rifles broke, catapults were absurd. Until inspiration struck at the Indian Head Naval Proving Ground when he noticed a discarded 60mm mortar tube lying forgotten in a scrapyard, its diameter perfectly matched to the grenade, and suddenly realized the fundamental flaw in existing designs, which all attempted to contain combustion rather than exploit it, because if the rocket motor burned completely inside the tube, the launcher would protect the operator instead of endangering him, eliminating backblast while delivering sufficient velocity. Working alone in a borrowed shop, Uhl welded a grip onto the tube, wired an electrical ignition system using D-cell batteries, fabricated sights from scrap metal, and test-fired the prototype into the Potomac River, watching in disbelief as the rocket flew straight and true. Yet when he presented the weapon to the Ordnance Review Board, he was met with ridicule and rejection, experts warning it would incinerate anyone behind it, misfire unpredictably, or explode prematurely, insisting that rockets were unreliable novelties and urging continued reliance on established spigot mortar systems, until intelligence reports forced a reckoning by revealing that German engineers had already begun reverse engineering captured Allied rocket concepts, triggering an emergency competition at Aberdeen where only one weapon would survive. Uhl refined his design obsessively, reinforcing the tube with piano wire, carving a walnut stock to absorb recoil, perfecting propellant burn rates so the rocket motor fully combusted within the 54-inch barrel, creating a weapon weighing just 13 pounds with an effective range of 300 yards and armor penetration sufficient to defeat any German tank from the side or rear, only to arrive at the proving ground to discover that his precision sights had been destroyed in transit, forcing him and Skinner to improvise replacements from a coat hanger and a nail held together with tape, a solution that looked ridiculous but functioned flawlessly. As senior officers, British observers, and nervous defense executives gathered, each established system failed in turn under realistic conditions, missing a moving Panzer III, while the implications sank in that American soldiers were heading into battle without a viable anti-tank weapon, until Uhl stepped forward, raised his crude launcher, and rewrote military history in 5 shots, prompting General Barnes to famously compare it to Bob Burns' musical Bazooka and then ask the only question that mattered: how soon can you deliver 5,000 units? Setting off a frantic rush into production that nearly destroyed the weapon's reputation through quality control failures, unreliable rockets, and inadequate training, leading to disastrous early combat reports from North Africa. Yet airborne forces saw what others missed. A lightweight, man-portable anti-tank weapon paratroopers could carry behind enemy lines, driving the development of the M9 airborne bazooka with breakable sections, magneto-ignition, improved rockets, and greater penetration. Ready just in time for Normandy, where on June 6, 1944, American paratroopers dropped into France. Carrying these weapons strapped to their bodies, assembling them in seconds after landing, and when German armor counterattacked, they did not retreat but hunted tanks from hedgerows and ditches, destroying dozens of armored vehicles and shattering German assumptions, forcing panzer crews to fear infantry for the first time in the war, proving that the crude drainpipe mocked by experts had not only worked but permanently changed warfare, even as German engineers raced to answer it with weapons of their own, ensuring that Edward Uhl's simple idea would echo through every modern battlefield where infantry and armor collide.